these setups is not so, is understanding exactly what they're talking about. The arithmetic, the math itself, isn't what's difficult. Now, when we did an example like this about costs rising, sales decreasing, we did something. Yes, sir?
How do we like store workers? Because we do know.
What'll happen here on the test stuff, I'll ask you to write down the equation, write your equation, and then solve it. Stuff like that. It's very specific. It's very, very specific. In this case here, I would hope. No, we'll see where we go here. With this here, if you remember from our example in class, you had two things that were going on. If you recall, we set this up as a quadratic. We knew that these were all modeled to be a quadratic, which means we have two terms. So when I'm given a problem like this, I'm selling 200 pairs of shoes when I charge 60 bucks. Those are my first two values. I'm selling 200 shoes at 60 bucks. If I multiply those two numbers together, that tells me how much money I made. Do you agree? Okay. Now, what this problem is asking me is that for every dollar I increase in price, I'm going to sell 2 fewer shoes. So, which one of these am I increasing by 1x? 60. What am I doing to this? Very good. Subtracting 2x. Now, this is a quadratic, which means I can set that equal to 0. What I want you to think here is what's going on. Hey, there's crabs. What's happening in these cases is that this curve crosses the x-axis twice. Do you agree?
Yes.
All right. Where?
Negative 60 and 100.
Very good. What's happening here, it's crossing the x-axis at negative 60 and 100. What we're doing here is we're finding the zeros of the terms, just like you did when it was x plus 3. We subtract 3 to solve for x. The only thing that's different is that the x is on the other side and the numbers are bigger. That's it. That's the only thing that changed. The numbers got bigger. That's how you get those two zeros. We know that, oh, I got checked.
Thank you.
Not a problem. We know that this curve is going to do that. And the reason we know that is because they asked for the maximum. Curves that are down like a frown have a maximum value. Think of a roller coaster. When you go up, it's going to come down. Now, what happens here at this point, you can put this in your calculator and you have to start searching for your window. Big pain in the butt, right? Now, if you do this, knowing that you have, with these terms, knowing that you have zeros, what happens halfway between? The axis of symmetry. Do you agree? Now, this is a very easy thing to figure out. What's negative 60 plus 100? 40. What's half of it? 20. The axis of symmetry is at x equals 20. Oh. That's the x coordinate for your maximum value. Okay? That's your x coordinate here. Your y coordinate, well, this is in terms of revenue, is your revenue. Pretty much. Now, a couple things you can do here. The x value is just 20. It doesn't mean you're selling it for 20. It means you're increasing your price to be how much? $80. Because it asks you how much could you increase it to maximize your profit. Well, if I sell it for 80 bucks, I'm going to maximize that out at whatever the 12. What was the 20 was y coordinate? Was it 12,000 something?
12,500.
There you go. That's what that means. The 20 isn't the price. The 20 is the increase of price. Yes, ma'am. Midpoint. You know what's happening there? You have the axis of symmetry that you fold in on themselves. All I do is find the average. It's the halfway point. Okay. This is 80 away from 100. This is 80 away from negative 60. Okay. That's how that works. You do the same general process for any one of these style problems where you have money involved like this, increase in sales, it's a lot cleaner to get that middle value instead of trying to search all day long for your window. Now, searching for your window, it will work. You will get it. It just takes a while to start playing around with it. Okay? Same thing goes for if I'm doing the electronics one. If I'm looking at the electronics, my two values were $680 for what I'm selling the camera for, and I was selling 70 of them a month. So right off the bat, I know that I have the 680 and the 70. If I decrease the sale price by 20 bucks, I will sell 5 more. So what do I do to the 680? Subtract 20x, and I add 5x, and I set that equal to 0. Okay? When I do that, I can do one of two things. I can go right to my calculator, start messing around looking for the window, or get the y value, or excuse me, get the zeros right away, and build out. If I get my zeros, I have 680, it's going to equal 20x, so I'm going to get 34. Yeah. And the other one is negative, is it 14? I know we're going to have a maximum because it said find the maximum, so we know that the curve's going to go down like a frown. Are we okay with that? The x-coordinate is the midpoint of negative 14 to 34. 10. Very good. So when x is 10, that's not the sale price. It's how many times I can take 20 away from the 680 to get the most money. How can I maximize my profits? I would sell it at 480. If I sell it at 480, I'm going to sell, 570 of them. I think that would, no, so, I'm sorry, I'm thinking of something else. I'd be selling 5, 10, 50, 100, I'm selling 100, I would sell 120 of them a month at $480 for a maximum profit or a maximum revenue of $57,000 and change. Now, I'm assuming that walking through this to find those zeros makes sense, doesn't it? Okay. Here's what you can do in your calculator along the same lines. What I would do is I'm going to go to my y equals, I'm going to put this function in. Parentheses 680 minus 20x, and then 70 plus 5x. Now, when I do that, instead of when I look at the graph, remember, it's going to be all weird. I might see it, I might not see it. I mean, it just takes forever to go through to find windows. Knowing what we know about where it's going to be placed, I know that at 10, just from working with those two zeros real quick, I know when the x value is 10, my y value is at its maximum. So just go to your table, and go to 10. Oops. My table said that to go there. At 10, it's 57,600. Okay? Your table will do that for you. It's just a little bit quicker to work it. When you have this style of problem, it's a little bit quicker to work via zeros to find that x middle point. Yeah?
You notice like 9 is like 57,500 and 11 is 57,500. Potentially, could you just put in the equation, go to the table, and look through it to see if it's there?
Yeah.
Okay.
Yeah, and it works out nice when it's clean numbers like this. There are times like in the Canon shot one where it's a little bit weird. Okay. Now, what I want you to think of when they're talking about the Big Bertha problem, they're starting at 0 where the cannon is shot from. How far away does it land? Well, you take the cannon and go, kablooey. Okay? You're trying to find out this horizontal distance that it flew. Well, when I go to my calculator in this case, I'm going to put in the model that they gave us, 101. If I put my model in at, was it negative 0.0196 x squared plus 1.37 x, and I graph it.
I have nothing.
That's fine. What I want you to think of is, are you going to have any negative values for a cannon? No. So why not just, yeah, why not set your x maximum? Think of it, just think of it logically. Is a cannon going to shoot more than 200 miles? I mean, if it was a rocket, okay? So set your x maximum to be maybe 200. Is your height of a cannon shot is going to be more than 50 miles up in the air? No. So that's a lot of gunpowder. So change your window to maybe have an x maximum of 200 and a y maximum of, well, I have it at 50, so I already knew it worked. So if I graph that again, I start to see it. There it goes. Okay? Everybody all right with that? So that means that somewhere there is another zero. It's going from a positive value to a negative value somewhere out there. So, look at your table. Just scroll. It's very fast to scroll through this. Unfortunately, it just takes a while. Look, I'm not even working. Oh, looks like I'm starting to decrease. Oh, I'm at 60 and I'm decreasing, so I'm almost there. Almost there. Almost there. Oh, there I went. Okay. Somewhere between 69 and 70 miles, it goes from positive to negative, which means it exploded. Death and destruction. Basically, that's the equivalent of shooting the cannon from our parking lot and hitting Lake Michigan. It's about 70 miles. Seriously, that's about how far that is. Yes. It was built as a big birthday. It was huge. They shot from Germany to France, or Germany to England. It really is that big. So your distance here, this value is about 70 miles away, give or take. Which means the maximum height happened where? Halfway between 70 and 0 is how much? 35. So when x was 35, what was the y value at that coordinate?
23.9.
So about 24 miles out. So the cannon shot up about 24 miles, and then it shot. Yeah. Okay. Whatever the x value, what the y value was. Remember, what you're doing here is you found. We're not measuring with like a perfection here. What you're looking at is thinking about what that means. The cannon was on the ground. It shot. The shell was even with the ground. It shot out, went up and over. It's about 70 miles away. The specific decimal equivalent isn't so bad. No. It hits about 70 miles away. I'm not really worried about what the decimal is. That means between 0 and 70, that to be the midpoint is 35. The y value at 35 was however high up it went. Horizontal and vertical distance, x's and y's. That's all it meant. Okay? You're using the calculator to help you visualize something that's not that abstract. Which gets you into the other ones. I'm guessing that the area ones weren't bad. From what I heard is that most people just forgot how to do the area of trapezoid. Yeah. It's 1/2 the base times the sum of the, 1/2 the height times the sum of the bases. You just get some crummy value here. It's like some weird roots, if I'm not mistaken.
Is there root 30?
Yeah, something like that. When you get to the other ones here, 89 was worded so poorly, and I do apologize for not telling you guys, that you're setting your D value equal to 80 to make that, because you're just mirroring what it did on the other problem in the book. And then what you're saying is that that value was when it was dry, so they're setting it up with that to see what your new maximum speed would be. So you go through the whole rigmarole with this model. You're setting this equal to 80. And you just solve it by completing this, or not completing the square, or quadratic. I would use quadratic. With decimals?
Yes.
You're a glutton for punishment.
Yeah.
But you know what? That's not that bad. 1.1 is
It was pretty bad.
yeah, that's awful. What I would have done here is just done 0.08x squared plus 1.1x minus 80. And I would have done the quadratic because of the decimals. What happens is you get two values at the end. You got a positive and a negative value, and they're talking about speed. Do you have a negative speed? No. So you just have to throw. Yes, sir. It was, oh yeah, because I have to set aside equal to 0 to use the quadratic formula. So what I'm doing here is I'm setting this equal to 0. Sorry, I forgot to write that. It was given to you from the problem before that, in that example. That was already a pre-calculated part. I forgot to tell you guys to go back. It was an example number 4. This brought up a really good question earlier. When it comes to the test stuff tomorrow with the word problems, they're extremely straightforward. There's not anything that you have to come up with your own stuff. Any of the models that you, like in some of these word problems where you got to come up with your own, the cost ones you can do, but where they're giving you something like this, I'll give you that. I'll give you that information. And I also know that I want to talk about that, what do you call it? That's 5-6 here in a second. Okay. So in this one, all you had to do is use quadratic formula. What's up, Christian?
I completed the square with all the decimals right and everything, but then I messed up on my very, very last thing. I accidentally subtracted on one side instead of.
That's awful. I want to show you one different thing here with the shot put problem. I want to show you how it mirrors the same idea of the Big Bertha cannon shot. What's different between this and the cannon? It still has the same curve. What's the major difference between this one and what the cannon one looks like? Where did the cannon shot start from? 0. Where does this one start from? It's the only difference. What's happening here, instead of the cannon shot was starting from the ground, this one's starting where she's holding it, 5.5 feet up in the air. That's what that means. So if you model this out via just graphically, you're starting your throw already here at 0 and 5.5 is your initial spot. Because you're starting here and you're throwing. It's still going all the way out here and still landing at some 0 value. All you have to do is figure out where that hits. Again, what I would do is just use the quadratic formula. If I use the quadratic formula with that, I'm going to get a positive and a negative value. And obviously my negative value isn't right because I'm not throwing it behind me. I was throwing positive. Does that make sense? Or really, really bad at shot put. Okay? All right. That's what you're doing on this. Same basic principle. You just have an initial height as opposed to being starting at 0. Okay. It went to the table. You'll see where it drops. You'll see where it goes from positive to negative, but it's not going to tell you the exact. I'll ask you tomorrow to round it out to like the nearest 100. You know, you can't just go, oh, it's at like 22-ish feet, or whatever it might be. I'm not sure what it is. I'm sorry, what was it? No, I usually round it 100. What's that?
It's like 46.
Okay, well, whatever. I forgot what the number was. Chris, what do you got?
Are there going to be like a ton of problems like this on this test?
It's a handful. I mean, it's not like 1,000.
Was there like many as this one?
No. Yes, ma'am. Which one? On the next group? The 5, 6? I'm getting there. Oh wait. I think the other one was, yeah, we can do that one. Yes, sir.
Was there a graphing half to this chapter you said?
Yeah, we haven't gotten there yet.
Okay.
Don't worry about 76 on this grouping here. It's more than what you will ever need to worry about here. It's a god awful. Yes, ma'am.
On our test, is there going to be any word problems?
Yes, I've said that like 5 times. If you hold your hair back over your ears, you hear better. I'm joking. 75. Now, one of the things with this is that you had to understand what the original model was. And I think I forgot to tell you guys where that was. These types of problems, 75, the rest of these, here, I'll get you 1 second. The page before, all these types of problems with initial velocity, here's what I mean. What's the difference between this and this?
Well, actually, if it hits, oh wait, no.
There is just drop, there's no, just let it go. This one, I threw it, so there was a velocity, which gave the R. Okay.
So right here, we just did right
No, and unfortunately, and I think we ran out of time yesterday. This is right here. You had to turn back 2 pages to get your initial velocity. Now here's the deal. If you have a problem tomorrow that requires the use of initial velocity style problem, I'll give you the generic formula. You just have to know how to use it. Let me explain what this does. Initial velocity style problems are for when you're throwing something or launching something. What I'm looking here is that. You're going to model it out. All initial velocity problems have the same thing. And like I said, if you're going to have to use that on a problem, I will put it in the problem. You just got to fill in the blanks. That V subscript 0, VO, is original velocity. People usually just call it initial velocity. H subscript O, that is original height. The 5.5 where she was chucking the shot put. She was 5.5 feet off the ground. Her initial velocity of that problem was that 1.37, whatever it was, feet per second. Okay. So in the model that you guys had here with 75, first thing you want to look at is, well, what's he doing? Cliff diving. Well, there's a cliff, and there's water. Right? He's jumping up and out, and he lands in the water. It's a sort of parallelism. Okay? He's starting at the initial height of 92 feet. He has an upward velocity. He jumps up and out at, 5 feet per second. So when you use your model, -16t squared plus your initial velocity plus your initial height. Your original height is 92, and your original velocity is 5, and it's positive. The reason that it's positive is because he's jumping up. Okay? So he's jumping up. So you just fill in the blanks. and I just use the quadratic formula to solve for t. You're looking where t equals 0. Okay? You want to set up to t equals 0. Yes. Oh, it'll be good. That's all. It's a constant of gravity with these two. Okay. So as I'm going through this, oops, opposite of b plus or minus the square root b squared minus 4 times a times c all over 2a. From last hour, I believe the radical is 5913. Now, they're giving you two answers. One will be positive, one will be negative. Do you want the positive answer or the negative answer? Positive. So that means you have to figure out which one you're going to use, the positive root 5913 or the negative root 5913. What are you dividing by? What do you want your numerator to be then? Negative. Because what's negative divided by negative?
Positive.
So you want to use the negative. Two and a half-ish seconds, I think. I think it's 2.5, unless I'm thinking of a different problem. Is it 256? Yeah, I think that's what I remember seeing. You were this close. All right. So when you're using these type of modeling ones, they're giving you the model. You have to figure out how do you use the info out of it. When you're using the one in the next problem where they're talking about spiking the volleyball. Spiking the volleyball has the negative velocity because you're hitting it downward. So when you fill in those, the ball starts at 10 feet above the ground, downward velocity of 55 feet per second. How long does it take for t to equal 0? There's a lot of words in here for just needing to know the given info. So negative 16t squared, well, minus 55t plus 10. Use the quadratic formula and go. Okay. It's the downward hit, so it's a negative velocity. Just like if you throw something down, you throw something up, it's got an upward velocity. It's good times. I think this one is the one that's like 1 point something seconds. Well, makes sense. You spike a volleyball, it doesn't take long to hit the ground, does it? I hope. Now, the other last ones that were thrown in there, they gave you the model. They gave you the formula that you were using. Okay. If I'm looking at the airplane one, they tell you that the S stands for the airplane's speed. The length is 2,000 feet. How fast can you go to equal 2,000 feet? So you just set the equation equal to 2,000, solve for S. You're looking for a positive S value. Okay? That's what you're looking to do. What's confusing? Oh, well, it's like. So it's 0.1 x squared minus 3x plus 22, and I want that to equal 2,000. So 0.1 x squared minus 3x minus 1978 is 0, I believe. I'm gonna use quadratic formula because I'm not gonna do anything else with that. Opposite of b plus or minus square root b squared minus 4 times a times c all over 2a. So when I put all that together, I have 9 minus 4 times 8. My discriminant is 800.2. Obviously, I'm going to use the positive value because I want negative times. So I'm going to take 3 plus the square root and then divide that by 0.2. And it looks like I get 156.44. Is that, I think it's miles per hour, I think we're doing it. I think 156 feet per second is kind of quick. Well, let's see, 156 feet per second, that would be,
That's pretty fast.
that is fast.
That's fast.
It's the maximum speed they're allowed to run at, so it would be.
It's not like you're going 88 miles an hour in a DeLorean.
Well, it's not that fast.
Nobody?
I got it, I'm just not laughing.
So let's see, 60 seconds in a minute, 60 minutes, an hour, and then mile. I am so surprised at the amount of people that don't know how many feet are in a mile.
5,280 feet.
I know it's 5,000. How many yards?
Oh, it's not that fast. 156 feet per second is only 106 miles an hour. That's not that fast.
There's no way a small plane can get that fast, actually.
I didn't care about that. I was just saying. I was just wondering how much feet per second. I thought it was like I highly doubt an ultralight's gonna go. 79 and 80. Again, if you're looking at 79, you're doing the same idea. You just set that equal to 60.
60 billion?
Just keep it at 60 because it's in billions.
Oh.
That's why your calculator would do everything.
Yeah, that's what I got.
The amount A in billions of dollars, so it's 60 billion. You don't have to write out 60 billion billion.
No, I did.
No, don't do that. Okay. In 80, there is no the height here starting at 0 because where does the lava start? At 0 and it goes up. It starts underground, but it's besides the point. The initial velocity of the lava, what is it? What's the coefficient of t?
Negative 16.
That'd be t squared. What's the coefficient of t?
4.
350. Remember, this model, this model here is the negative 16 t squared plus your initial velocity times t plus your initial height. The coefficient here is your initial velocity. Your initial height just happens to be 0. Okay, it's 0. The maximum height then, well, I would just use my graphing calculator to figure out where the maximum occurs. Negative 16x squared plus 350. Put that in the calculator. It's over in this corner, so I'm going to shorten it up a bit. I'm going to change my window back to a maximum of maybe just 20. See what happens. All right, so it happens quickly, so just have to raise the Y. Oops, that's one more.
Not enough.
200 is not enough, bless you. It's close though.
300 is not enough.
There you go.
500 is enough.
And just find your maximum. Yeah. All right. That's how that stuff works. Now, when you're working word problems, guys, the models, like these last couple in 5.5 and 5.6, they gave you the algebraic model that you had to work with. Don't worry about initial velocity ones, about having to memorize out that negative 16t squared. I'm not going to require that you do that. If it is an initial velocity or initial height style problem, I will put that in there. The negative 16t squared v sub o, I'll put that part in there so you just have to work from that. Is that fair?
Yeah.
All right. Really, the only other stuff on there tomorrow is just some simple factoring and how do you work with imaginary numbers again. All right. It's put it all back there. So,
Was this section 2 portion?
did that clear out a lot of the confusion that you were probably having with word stuff? Wasn't as bad as I was hoping. Michael, I'll get a bunch of paper started for you guys. Yes, ma'am.
Can I still come in during the I'd like to finish the homework.
Not a big, I'll get that stuff for you guys tomorrow, that way if you have to finish it up or whatever, it's not a big deal. I'm not too overly concerned. We did it, just did a whole.